Yes. Do you have any doubt from last class?
No, sir.
Ellen,
No, sir.
so tell me what we had done last class.
Sir, in last class, we have done some more questions on conversion of unit, and we have started with error analysis, and we have studied about accuracy and precision.
Okay, good. Next topic is to define significant figure and a rounding off. Ifra, do you have any idea about it? What do you mean by significant figure?
Yes, sir.
Just explain.
Sir, all the non-zero digits are significant figures, and the zeros which are on the right side of the non-zero digits with a decimal point are significant, and
These are rules to find significant figure. I'm just asking about what do you mean by significant figure? I'm giving you one example. Suppose if you have to measure length of a particular rod, let's say this particular rod. So what you do, you just place any meter scale ruler like this, which having some measurement starting from 0, 1, 2, 3, and so on. It will be 1, 2, and so on. 1 and 2 or between any two consecutive number, there would be difference or there will be division total of 10. So it would be 1, 2, 3, 4, 1, 2, 3, 4, and so on. So if you observe this particular length by using this particular ruler, the observation may be of 3 different types depending upon observer. Let's say if someone observe it from this side, let's say from this inclination, you will observe as 2.3 for this particular measurement. If you observe the same reading from this side, you will observe it as 2.4. So the reading from these two different observations would be 2.3 centimeter, and from this it would be 2.4 centimeter. So depending upon observer to observer, this particular numerical value for the measurement of this rod would vary. But in this particular measurement, just see, we have first digit as 2 in both cases, and next digit is 3 in this part and 4 in this part. So we can say the last digit would depend upon the observation or the observer in which direction he is taking the observation, whether he is saying exactly perpendicular to it, whether he is observing it at some inclination towards left, towards right, or any other direction. Depending upon their observation, this large digit number would vary from observer to observer. So we can say the first digit in this particular observation is called true value, and the last digit, which may vary depending upon observer to observer, is called uncertain digit. The total number of digits in true value plus one uncertain digit in any of the calculation is called significant figure. Is it clear? So
yes, sir.
significant figure simply defines you the number of digits in true value plus one uncertain digit in any observation is called significant figure. Ellen, is it clear to you?
Yes.
Now we have certain rules regarding calculation of this particular significant figure. So let's say rules for counting number of significant figures. I'm defining all of decimal number first. First, all non-zero digit are significant. Next, if zero lies in between two non-zero digit, then it would be significant. If zero lies in between two non-zero digit, then they are significant. It means if you have 0.504, if you have 0.2005, so in this first example, we have 1 0 in between two non-zero digits. So all three digits will be significant. Similarly, in this example, we have 2 0 in between two non-zero digits, 2 and 5. So it all 0 in this particular observation will be significant figure. Now, if 0 lies right to decimal but left to non-zero, then they are insignificant. Suppose if you have 0.05, so in this particular observation, we have only one digit that is non-zero. So it will be 0.0502. This zero is right of decimal but left of a non-zero, so it will be insignificant. But this zero is lying in between two non-zero digits, so it will be significant. So you can say it is significant, but this is insignificant. Is it clear, Isra, till this part?
Yes, sir.
Okay, just write it down.
So done.
Next is if 0 lies right to decimal and right to non-zero, then they are significant. Suppose if you have 0.020, so this 0 is left to a non-zero digit, so it will be insignificant. But this 0 is right of non-zero digit, so it will be significant. And we have 2 as non-zero digit, so these two terms would be significant. Next is exponential is insignificant. Exponential is insignificant. If you convert one unit into another, the number of significant figure in total would remain same, while converting values from one system to another, number of significant figure will be same. I'm giving you some example, try to solve it. Find number of significant figure. Try to solve. Good, Ifra. Ellen, have you solved? Okay. Next. Good. Good, Aline. Good. In last example, we have non-decimal number. So if 0 lies right to a non-zero digit in any non-decimal number, they are insignificant. So in this part, we have only two significant here. Okay. Now, how to calculate significant figure on the basis of different operations, addition, subtraction, multiplication, and division? I'm defining that. Have you written to this part?
Yes, sir.
Ellen?
Yes, sir.
Okay. Now, next is if we have to add or subtract, let's say 4.32 plus 1.5. Just add them. On adding, you will get 2, 5 plus 3, 8.5. It means 5.82. Now, try to check which of this number is least precise. Precision simply depends upon number of significant figure after decimal. In this part, we have two significant figure after decimal. In this part, we have one significant figure after decimal. The more the number of significant figure after decimal in any of the observation, it will be more precise data. So you can say the more number of significant figure after decimal, the more precise data it will be. So according to the law of significant figure, it simply states you while addition or subtraction, the result of this observation or this operation would be reported in terms of least precise data related to input. So it simply tells you while add or subtract, the result should be reported in least precise data related to input. Alan, just tell me which of these input is least precise?
1.5.
1.5. How many significant figures are there after decimal?
1.
1. So the final answer must contain one decimal number, one significant number after decimal. So it will just be 8. So now we have to round off this particular number up to 2-digit number or up to 1 place digit after decimal. So for that rounding, check the next digit. It is just 2. According to the rule of rounding off, whether a number contain 0 to 4, there will be no change. But if it contain 5 to 9, just increase the next number by 1 if it is not even combination. So here we have just 2, so we can neglect it. So your final answer would be just 5.8. Is it clear?
Yes, sir.
Next is multiplication or division. Suppose if you have to multiply 4.32 into 1.5. So what you will get? 15 into 2, 30. 15 into 3, 45. plus 3, 48, 15 into 4, 60, plus 4, 64. We have one place digit and we have two place digits. So in total, we have three places of decimal. So it will be at this point. Now, just calculate the total number of significant figure as a whole. So we have three significant figure in this part and two significant figure in this part. The total number of significant figure containing any observation is defined as its accuracy. The more number of significant figure in any observation, we can say it will be more accurate data. The more number of significant figure as whole in our data, it will be more accurate. So according to the law, while multiplying or dividing, the results should be reported in least accurate data related to input. So we can say while multiply or divide, the result should be reported in least accurate data related to input. Ifra, tell me which of these two observations is least accurate?
So 1.5.
How many significant figures are there?
What, sir? Can you please repeat your question again?
How many significant figures are there?
So 2.
So the final answer of this particular multiplication must contain two significant figures. So now we have 6.4 and next is 8. So we have to round off this particular number to get it just two significant figures. So what will be your final answer?
So it's 6.5.
Ellen?
6.5.
Wrong. Just say we have 8 and next to be rounded off digit is 4. Whether they are even or not?
So they are.
If combination is even, they can't be rounded off. Okay, this is the exception. Rest of the whole combination will be rounded off if the digit would be more than 5. So you can simply write it as 6.4. Is it clear?
Yes, sir.
Yes, sir.
Just write it down. You may write as 8 and 4 is even, so they can't be rounded off. You may write it as 4, and 6.
So done.
Done, sir.
Okay. So you've just finished the significant figure and rounding. Next is, what do you mean by error? Ifra?
Sir, any mistake?
Okay. How could you conclude whether you have done any mistake or not? So you'd say there would be some true value, and you must have observed or taken observation related to that given measurement. So there should be some experimental value. So analyze these two different values, true value and this experimental value. The difference in these two values would be treated as error. Okay. So error is nothing but the difference or deviation in experimental value with respect to true value. Is it clear?
Yes, sir.
Yes, sir.
Now we have mainly two different types of error. First is called systematic error, and next is called random error. Do you have any idea about these two terms? Ifra,
No, sir.
Ellen?
Sir.
Okay. Let's say if you have systematic error, it simply defines you the error in the instrument itself and which can't be reduced by human. Let's say if you have to measure the length of a particular object by using any metallic scale, metallic ruler. Suppose you have done your calculation in winter, and similarly, if you've done the experiment again in summer, whether your observation would change in two different situations or it will remain same, it will be changed. Why so? Because any metallic ruler or metallic body would change in its dimension depending upon surrounding temperature. In summer, its length would get expanded, so it would measure lesser value. But in winter, it gets contracted, so it will measure the same particular object slightly longer. So these two observations are the error caused in these two different seasons, which we call as systematic error, on which human can't have control over it. Okay. So those
Okay.
type of error are called systematic error. Next is random error. It is based due to human mistake, and only this random error, which we can be minimized according to the taking number of repetition. That's why it is strictly assigned to a student to take more and more number of observation related to any observation or any experiment. So you can say random error arises due to human mistake while taking any observation, while taking calculation or any term. So it can be minimized by increasing number of repetitions. So random error is inversely proportional to number of repetition. Just write it down. So we mainly define random error only. Okay.
Done, sir.
Done, sir.
For this random error on defining something, let's say you have some experimental value x1, x2, so on to x. These are some experimental value related to an experiment. So from this data, first of all, just take the mean of all observations. So it will be x1 plus x2 plus so on to xn, divide by number of observation n, or we may write it as summation xi divided by n. This is nothing but mean value or average value. In terms of calculation, it is called as true value. Now, try to take the deviation or difference of each data with respect to its true value. So we can call it as deviation. Let's say delta x1. So it would be x1 minus x bar. This difference would may be positive or negative. So you have to take only positive value. That's why just assign modulus or absolute value. Similarly, delta x2 would be equals to x2 minus x bar mod. And similarly, delta xn is equals to xn minus x bar and mod. Now, if we take mean of this all deviated value, let's say delta x bar, so it will be delta x1, delta x2, and so on to delta xn divided by n, or it will be summation delta xi divided by n. This is nothing but absolute mean. Is it clear to this part?
Yes, sir.
Now, from these two different values, you can write your result as true value plus minus the deviated mean, or we can say absolute mean error. So it will be x bar plus minus delta x bar, or just remove this part. So it will be x plus minus delta x. Now from this observation or result, you would find two different terms. First is called fractional or relative error. represented by delta, which is equals to delta x by x. Now, if you multiply this observation, you will get percentage error, delta percentage, which is equals to delta x by x into 100. So for any of the calculation, you have to find four different values. First is true value, just take the mean of all individual data. Next is try to get deviated or deviation, and then take the mean of all deviated values. So you can call it as absolute mean error. And on the basis of these two terms, you will define fractional or relative error by take the ratio. And if you multiply the ratio by 100, you will get percentage error. Is it clear, Ellen?
Yes, sir.
Yes.
Just try to. Yeah, I'm giving. Just wait 1 minute. Ellen, done?
Yes, sir. Done.
If time period for oscillation of simple pendulum are 92 seconds, 93 seconds, 95 seconds, 94 seconds, and 93 seconds. Find first true value, second absolute mean error, third fractional, and fourth percentage error. Try to solve. First of all, just send me the value for true value. It's 94. If I just check your calculation,
Okay, sir.
good, and then so you'll get T bar is equals to 93.4 second. Okay, Fran?
Yes, sir. Now I got it.
Okay. Now we have in this particular result 3 significant figures. And how many significant figures are there in this input?
Sir, 2.
So what will we do now? Just
Okay.
round off your result up to 2 significant digits. Okay. So on rounding off, it will become just 93. Is it clear?
Yes, sir.
Not a deviation. If not, just check your calculation. For all of the deviating value, you have to take absolute value only, whether it be negative or positive. You have to take only the positive part.
Okay, sir.
Yes, Ellen, you have to take mean of this observation. So just sum up this whole and divide by 5. So delta T bar would be equals to 93 minus 92. It would be 1, 0, plus 2, plus 1, plus 0, and 4 divided by 5. So it would be 4 divided by 5. It would be just 0.8. Is it clear, Ifra?
So, but when we will minus 92 from 93, we will get minus 1.
Just see here. I have defined for any of the difference, you have to take absolute value only. So in absolute value, whether it would be minus 5, you have to take more, means magnitude only of this particular number. So it will be just plus 5. Okay,
Okay, sir. Now I understand.
good. Ellen, just see this calculation. 1 plus 0 plus 2 plus 1 plus 0. So it will be 4 divided by 5. So it will be 0.8. From here, where you got 0.005. While taking mean, sum of observation divide by number of observation. So we have mainly 5 observation in this data. Now try to solve for fractional error and percentage error. You would write your result as true value 93 plus minus error part 0.8 second. fractional error is equals to delta t divided by c. So it will be 0.8 divided by 93, or while taking percentages, just multiplied by 100. So it will be 0.86% and it will be 0.0086. Good again. So we have just defined this whole 4 types of different error. Is it clear, Ellen?
Yeah.
Okay.
Yes, sir.
Now we have to define operation related to these errors. So how to define it? Let's say operation on error, or it will be written as combination of errors. Suppose if you have input as a plus minus delta a, so first part in this observation would be true value, and after plus minus in terms of delta, it would be error related to that measurement. Similarly, b is equals to b plus minus delta b, and r is equals to r plus minus delta r will be final result. So this a and b is input and this r is output. Now I have to define relation with respect to r in relation with a and b for different mathematical operation. Suppose for the first addition, r is equals to a plus b. Now write the values of each term respectively. So it will be r plus minus delta r is equals to a plus minus delta a, b plus minus delta b. So if we're rearranging this term, so it will be a plus b as true part. And if we take out common plus minus from this two parts, so it will be delta a plus delta b. So this will be a final result. Now on comparing on left hand side and right hand side, you will get on comparing true value would be equals to true value. Error part would be equals to error part. And if you divide it, you will get delta r by r is equals to delta a plus delta b divided by a plus b. To define fractional error, and if we multiply it by 100, delta r by r into 100 is equals to delta a plus delta b divided by a plus b multiplied by 100. You will get percentage error. Is it clear, Ellen? Till this part,
Sir.
Ifra,
Yes.
read out. Okay.
Done, sir.
Done, sir.
I'm giving you one question regarding it. If R1 is equals to 10 plus minus 0.3 ohm, R2 is equals to 20 plus minus 0.5 ohm, find R equivalent in series. Try to solve. You must have learned in series resistance or individual resistance get added. Just use the result and try to simplify it. R equivalent in series combination would be R1 plus R2. Just put their values. Good, Ifra. And then just see this. We have 10 as true part of R1 and 20 as true part of R2. Similarly, we have 0.3 as error part of R1 and 0.5 as error part of R2. So according to the rule, true part would add it with true part, so it will become 10 plus 20 in first part, plus minus error with error, so it will be 0.3 plus 0.5. So on combining, you will get 30 plus minus 0.8. Good, Ellen. Oh. Now the next term is to define subtraction. Let's say R is equals to A minus B. So on putting values, it will be R plus minus delta R is equals to A plus minus delta A minus b plus minus delta. If you expand this, you will get a plus minus delta a minus b, and this minus on multiplying with this part, since this is error and error can never be negative, so it will be always positive. So take this as it is. So you can write error can never be negative. So it will be a minus b as true part. If you take out common as plus minus, you will get delta a plus delta b. Now compare these two different terms. You will get your answer as your true part from this calculation is a minus b. Error part is a plus b. And if you divide these two terms, you will get fractional error as delta r by r is delta a plus delta b divided by a plus b. And if you multiply it by 100, you will get percentage error. Delta r by r into 100 is equals to delta a plus delta b divided by a minus b and whole multiplied by 1. Here it would be minus sign. Is it clear to this part, Ellen?
Yes,
Yeah.
sir.
Yes, sir.
Okay, just write it down.
Sir, done.
Done, sir.
If temperature T1 is equals to 20 plus minus 0.3 degrees Celsius and temperature T2 is equals to 50 plus minus 0.5 degrees Celsius. Find first T1 minus T2 and second T2 minus T2. Try to solve. Good, Ifra. Ellen, just send your answer. We have to subtract. Alan, we have to subtract these two terms.
But how should we subtract?
Just say this result. While subtracting, true part gets subtracted with true part, but error will always be added. Okay. So from this, you can say in first part, we have true value as 20 and we have true value as 50. So while subtracting, it will be 20 minus 50. That would be minus 30. And plus minus error part, which will be always be added. So it will be 0.3 and 0.5, 0.8 degrees Celsius. Is it clear?
Okay, sir.
Similarly, if you subtract it from T2 to T1, it will be 50 minus 20, 30 plus minus 0.8 degrees Celsius. Is it clear now?
Sir.
Just try it. Ellen, have you written?
Sir.
Now the next part is to define how do we multiply on the basis of this error. So next is multiplication. Suppose R is equals to A multiplied by B. Now put the term related to each part. So it will be R plus minus delta R in first part, A plus minus delta A second part, and B plus minus delta B as third part. Now we have to take common as R in first part, but in this second part, it is only just delta R. So multiply and divide it by R. Similarly, multiply and divide by A, multiply and divide by B. Now, if you take out R as common from both these two segments, you will get 1 plus minus delta R by R, A as common, so it will be 1 plus minus delta A by A. If you take out common B, you will get 1 plus minus delta B by B. Is it clear?
Yes, sir.
Okay. Now, if you expand this, you will get A and B taken as outside. And if you start multiplying with each part to each term, it will be 1 plus minus delta A by A plus minus delta B by B plus minus delta A by A times delta B by B. Now, since if you have 0.1 multiplied by 0.2, your result would be 0.02. Which of these three numbers would be the smallest? Ifra,
Yes, sir.
in this part, which is the smallest?
So 0.1 and 0.2 both are having same significant figures.
And I just ask you, in these three numbers, which is the smallest?
So 0.02.
Yeah. So if you multiply two smaller number, you will get a further smaller number, that is 0.02. It would be smallest as compared to this whole. So you can say if you multiply two different small value, your result would be get much smaller, and on the basis of which you can neglect it. Now what we're left with? A times B as coefficient, 1 plus minus taken out common, so it will be delta A by A plus delta B by B, and is equals to R 1 plus minus delta R by R. Now on comparing on right hand side and left hand side, in left hand side we have R as coefficient, and right hand side we have A into B as coefficient, delta R by R as fractional error, and delta A by A plus delta B by B as fractional error. So on combining, you will say on comparing, R would be equals to A multiplied by B. Second, delta R by R is equals to delta A by A plus delta B by B. So this will be your fractional error. But if you have to calculate the error part only, so move this R to the other side, you will get delta R is equals to delta A by A plus delta B by B and whole multiplied by R. And if you want to calculate percentage error, just multiply the fraction part by 100. So it will be delta R by R into 100 is equals to delta A by A into 100 plus delta B by B into 100. Is it clear?
Yes, sir.
Helen,
Yes, sir.
you just write it down. So you have to remember the result only for any of the observation.
Done.
Done, sir.
I'm giving you one question related to this. If current is equals to 10 plus minus 0.2 ampere, resistance is equals to 20 plus minus 0.3 ohm, find percentage error in voltage. You must have learned in class 10 about Ohm's law, which is equals to voltage is equals to current times resistance. So if you have to calculate voltage, it is equals to product of current and resistance. Now in this question, we have to define percentage error. So just use this concept and try to get your result. So you will say delta V divided by V into 100 as percentage error in voltage. It would be equals to delta I over I into 100 as first part, delta R by R into 100 as second part, and the two are in multiplication. Now put the value of each segment and try to simplify it. True part for current is 10, error part for current is 0.2, true part for resistance is 20, and error for resistance is 0.3. Just put these values and simplify it. You have to calculate in percentage. Ellen, have you done? Tell me the value for delta I.
0.2.
Good. And I is
10.
multiplied by 100 plus delta R is
0.3.
divide by R,
20.
multiplied by 100. So it will be 2 by 100 into 100. So it will be just 2 plus it will be 3 by 2 or it will be 1.5. So in total, it will be 3.5%. Good, Ifra. Is it clear, Ellen?
Yes, sir.
Okay, let's try it done. Done.
Yes, sir.
Okay, so let's stop here. In next class, I will define you division and exponential of this error measurement. And then I will describe you some of the measurement related scale for measuring large distances, such as light years from the unit and parsec. Okay,
Yes,
okay,
sir.
just revise this whole. We'll meet in next class.
Okay, sir. Bye.
Okay.
Thank you. Okay.